Hello, welcome again to another advanced Python tutorial. So if you're new to this channel, please consider subscribing, liking, and leaving your comments below. So on this video, we're going to talk about sets. So without further words, let's get started. A set is a collection of data type that is unordered, mutable, and unlike list and tuples, set has no duplicates, so doesn't allow duplicates of elements. So a set is created by braces like dictionaries, but it lacks the key and value pairs, so it contains only single elements separated by commas. So for example, let's say my set equals to 1 2 3. Save this. If we print here, we need to print the set, print my set. So save this. So we are going to have a set of 3 elements. Now if we like to put duplicates, like let's say we can keep here 1 and we can have another 2 here. If we save this and try to print this, okay, this proves our point that sets do not allow duplicates of elements. So we see we only have 1 2 and 3 instead of these duplicate elements. We can also use the set function to create a particular set from an iterable. For example, let's give this to be a list, and then this should be a list too. So if we use the set function here and close the braces, so if we print here, we are going to have a set again. So we have a set. So you can also create a set by using the built-in set function, or we can also use the strings. For example, let's say my set equals to hello. Okay, if we save this and try to print here, see we have our set here. Just mind you that sets are unordered and they do not allow duplicate of elements. That's why the L here, we don't see it on our set. We can also create an empty set. For example, you can just create this, and if we print here, so we have the empty set here. Just we need to be careful when creating the empty set, because if you try to create an empty set like this, and if you save here and let's print and see, so we have this one. You may think this is a set, but if we check the type here. So if we check the type here, so we have the class dict. So we have to be careful here. You can't create an empty set like this. This is going to be treated like a normal dictionary. A set is immutable, so we can create and we can add elements to our set. For example, we have an empty set, so we can decide to say my set. We can say dot add, we can add 1. Same, we can say my set dot add, we can add 2, and say my set dot add, then we can add 3 here. So if we save this and we go to print, we are going to have the set which contains our 3 elements which we have added them. Okay, we can also try to remove an element from our set. So we may say my set dot remove. If let's say we are going to remove number 3 here, and if we save this and try to print it here, we see that our set remains with the 2 elements. So what happens if we try to remove an element which is not there? For example, 4 here. So if we print it here, we are going to have a key value error. A key error that we are trying to remove the element which is not inside our set. Also, to overcome this, you can use the other method which is called discard. Okay, so if we discard 4 here, let's save. So we are going to have our normal set, and we don't have again this error because the discard method doesn't print the particular error. We can also try to clear our set to make it an empty set. So we can just here we can say my set dot clear. Okay, if we clear this and save here, we expect it to have an empty set. So sure, we have an empty set here. Okay, we can also use the pop method. This will return any arbitrary value of our set. Also, it removes it. Let's do it this first. So if we say print my set dot pop, if we save this, now let's see what happens. So first it returns the element which is going to be removed, and then is going to be removed. We can also iterate through our set. Let's say for I in my set. Okay, now let's print I. So it's not necessary to be I here, you can put any value. Okay, so let's save this, and so we have our set here. So this is how you can iterate through your set. Now we can check an element if is within our set. For example, let's say if 1 in my set. Okay, let's print yes. So if we save this and print here, so we have yes, because 1 is within our set. Now we can also check for 2, so we're going to have the same answer. Okay, we can also check for 3, which gives also the same answer. Also we can check for which number which doesn't exist, and if we print here, we don't get anything printed. Okay, now let's talk about union and intersections. Let me create new sets here. Okay, we have 3 sets here. We have the primes, we have the evens, and we have the odds. So union, it combines from 2 sets without duplication. So we say U equals to, let's say, odds dot union, then evens. If we print U here, save this. So if we print this, we have our union set here. So let's try to see ourselves. So odds union the evens. Okay, 8, 9. So we have all the values here. We can also calculate the intersection of two sets. So the intersection will only take elements which are found in both sets. So let's say I equals to, now let's say odds the intersection, let's say intersection of evens. Now instead of union, let us print I. So let's save this. Now if we print here, okay, we have an empty set here. You know why we have an empty set here? Let's check the odds and let's check the evens. There are no elements which are similar from both sets. That's why I've said earlier that the intersection will only take elements which are found in both sets. Okay, intersection of odds to primes. Now if we save this and print it here, we have 3, 5, and 7. This is for sure. Here we have these numbers and we found them here. Now let's try to check the intersections of evens and primes. Let's say intersection of evens here, and then we check for primes here. Also we have just 2, so this is found in both sets. Okay, we can also calculate the difference between two sets. So let's create other sets here. Let's say we have our two sets here, so it is set A and set B. Okay, so the difference will return all elements of set A that are not in set B, or elements of set A which are not in set B. Now how can we do this? We just write diff, let's say equals to set A, okay, dot difference. Okay, so the difference of set B. Now if we print, and let's say what we're going to have. So we are going to have 4, 5, 6, 7, 8, 9. So returns all the elements which are not in set B, as we can see here. Now let's try it for set B. Let's say set B here, and capital B here, and let's say set A here. And if we print this, so we're going to have, that means it returns all the elements which are in set B and not in set A. Okay, there is a second method which is called symmetric difference. So here we can add symmetric underscore difference, and if we print this here, so we are going to have this one. Symmetric difference will return all elements that are in set A and set B but not in both sets. Okay, we can try the same thing to set B, set A here, and let's put set B here. So if we save this, and if we're going to print it here, we are going to have, so returns all the elements which are in set A and set B but not in both sets. For example, here we have 1, 2, and 3 which are in both sets. Okay, union, intersection, and the different method shown will not modify the original set. So they always returns a new set. You have to know that. But we can also modify our set in a place. For example, let's take these two sets of ours, and let us try to update set A here. Now let's say set A, let's say dot update let's say update set B. Okay, now let's save this. Let's print set A. Okay, so this is what we are going to have. If you can see here, if we update, it means that all our elements from set A, from set B, they are going to be updated to our set A. That's why you can see we have here a very, very long set here. Okay, you can also try to update for set B, but there is also an intersection update method, which we can say this. Instead of here, we can say intersection update. So we just try to update all the sets which are intersected. So if we print here, let's save first, and if we print here, we just have the elements which are intersected, which is 1, 2, and 3. So this updates sets by only keeping the elements which are available in both sets. There is also a method called different update. So instead of intersection, we call it difference update. If we save this and try to print it here, so we have this difference update here. So this, it updates the set by keeping the elements in set A and set B, but not the element that are found in both sets. Okay, let's now talk about subsets, supersets, and disjoint methods. Okay, let's have our new sets here. Let's reduce this set B to 1, 2, 3. Okay, and let us reduce this to 6. Okay, now save this and try to print. Okay, we say set A dot is, let's say, subset is subset of set B. Okay, control save, and if we print here, we are going to get false because we know that this will return false, because that means all the elements in set A are also in set B. So that means these elements in set A should be also in set B. Okay, but also we can try for set B. Let us interchange here. Let's put B here, and let us put A here. Yeah, it's capital A. If we save this and if we print this, we have true. Okay, you can see the difference here. This will return true just because we have 1 and 2, 3 here, which they are also in set A. Now the opposite of subset is superset. Instead of subset, we can say it's superset. Okay, save this, and if we print here, we have false. Why we have false here? Because superset returns true if the first set, it contains all the elements from the second set. Okay, I think we understood each other here. And as we can see that set A is a superset of set B because it contains all the elements of set B. Okay, let us try to exchange here. Let's put this A, and if we put B here, okay, if we print this, we need to have true. Yes, because set A contains elements, all the elements which are in set B, but when we had the B here, we had false because set B doesn't contain all the elements which are in set A. Hope this is understood clearly. Okay, now we can calculate if the two sets are disjoint. Okay, let's try to print set A is disjoint. Okay, is disjoint of set B. If we print here, we have false. Okay, so why do we have false here? Because disjoint returns true if both sets have no same elements. So we need to have a null intersection, and we need to have no same elements. So because here we have 3, we have 1, 2, and 3, 1, 2, and 3, that's why we have a false here. Okay, so in order to prove our point here, we need to create another set here. Let us call it set C. Let us give it 7 and 8. Now, if we save this, and now let us try to print set A is disjoint of set C. Let's put C here. If we save this, okay, now we have true here just because there are no same elements and there is a 0 intersection between set A and set C. Okay, now let us talk briefly about copying two sets. Let's say we have this set here. We try to say that set, let's say set B equals to set A. Okay, now we can say set B should be capital, should be set B dot add. Let us add 7 here, and now let us print let us print set B, and let us print set A. So if we print here, we have set B and set A, they have the same elements. This is okay, this is because set A and set B, so all of them are pointed to the same memory. So to overcome this, we have to use the dot copy method. So if we use here set A dot copy, and if we print here, you see that the set A doesn't contain 7, which we added later. Okay, we can also overcome this by using the built-in set method. So instead of using the dot copy method, we can use the set method here. So if we save this, we are going to have the same results, yeah, like this one here. Okay, the last thing I want to show you, it is called a frozen set. Okay, this is also a collectional data type. This is immutable version of a normal set. Okay, we know that sets are mutable, but frozen set is an immutable version of a normal set. So let's say A equals to frozen set is here, and then let's put a list here, and let us give it 1, 2, 3, and 4. So if we print A, okay, let's save this. So we are going to have a frozen set of 1, 2, 3 to 4. Now, if we, let's say if we try to add anything to our frozen set, let's say we say A dot add, let's say let us add number 5 here. And let us save this and let us print here. So we get an attribute error that frozen set has no attribute add. Okay, so this will give us an error because a frozen set is not mutable. Okay, we can also try to remove, let's say here a dot remove, let's say remove number 2 here. If we save this, we are going to have the same error. Okay, so if you are going to use a frozen set, or the dot add and dot remove method will not work. Also the update method will not work. But for union and the different method, this is going to work. So we have to be very careful using the frozen set.